Hello, everyone. It's my honor to introduce our efforts on building a unified API wrapper to simplify the web data collection. My name is Wang. I'm a senior PhD student in SFU Vancouver. I do research on data management problems. And my colleague Wei Yuan, who is going to show the demo, is also a PhD student, and he enjoys contributing to open source project. Okay, let's get started. Data collection is a critical step in data science lifecycle. Web APIs are the interface provided by the websites as a way to access their databases in a secure manner. Web APIs make it possible to access rich data resources that cover many domains. It's very common to collect data with web APIs. Here, I listed a few example APIs that many of us are very familiar with. The right-hand side is a very popular GitHub repo that collects many public APIs. And here, I just show a part of the domains that those API cover. You can imagine how much data behind those APIs. Although a big value, accessing such data resources can require advanced programming skills to facilitate the individual users. There are many popular open-source API wrappers in GitHub. They basically wrap up complex API calls into easy-to-use Python functions. However, to build such a wrapper is challenging. A functioning wrapper needs to tackle a few key components. First component would be to build the HTTP connection with the website server. Second, to handle the authorization for the user so that the user can just pass the credentials as the function parameters. And pagination, which is to combine data requested from multiple pages into one function call. Concurrency is to accelerate the data request process with parallelism implementations. And the wrapper also handles the result parsing, such as converting JSON results to a CSV file or pandas data frame. There might be other customized ones. And building a wrapper for each website is not only difficult, but also not scalable. What I mean is that existing wrappers are built in a web-specific way without considering their commonalities. In this way, every time the developers would build a wrapper for a new website, they will need to implement those key components over and over again. That's huge repetitive engineering efforts from the user's perspective, because those wrappers are customized for the websites and implemented by different developers. The user will have to learn how to use a new wrapper over and over again as well. And our vision is to unify the API wrapper building process so that it saves energy for both developers and users. And our library is called dataprep.connector. The key idea is to implement the general components that are shared among all websites only once and describe the website-specific information in configuration files, such as what authorization and the pagination scheme the website uses. For developers, building a new wrapper is just to write a new configuration file. From the user's perspective, they can query different websites with a very simple and similar syntax. When they call the functions, the library reads from the configuration file, assemble the request, and execute. Here is an example of how to search the machine learning papers in DBLP. Users only need to provide the minimal input, like authorization tokens and query keywords. The process to query the Spotify is pretty much similar. Here's how we connect to Spotify and query the album search API. And next, Wei Yuan will do the demo.
Thanks, Pei. Next, I'm going to show you two features of the connector. It's easy to use in that you can collect data from a website in 3 lines of code. It's also fast to use in that you can collect data from a website in parallel. Now, let's imagine we want to collect data from a website called DBLP. DBLP is a computer science bibliography website, contains publications, authors, and venue information. This is a website of DBLP. On this website, you can see there's a search box here. You can input search keywords to do search. For example, I can type in scikit-learn. This will return you the publications that are related to this search keyword. You can see here it returns 21 matches of this search. I can also search for CVPR 2020, which is a computer science conference focusing on computer vision. Now, for this search, I get 1996 matches. Think about what if you want to get these search data using Python. Luckily, DBLP provides you an API page, which contains 3 API endpoints: publication search, author search, and venue search. It also contains a bunch of parameters to be issued along with requests to these API endpoints. For example, you have a parameter queue for which you can put a query string in it. For example, in our case, we can put CVPR 2020 into this parameter queue. It also has parameter edge, which indicates the maximum number of search results to return for each request. By default, it's 30. With all this being given, it's still not easy to create Python code to issue HTTP requests and get data. This is because you still need to manually compose HTTP requests. For example, you can use a Python requests library to do that. And also, you still need to parse the response from the returned raw JSON. Let's see how we can use the connector to simplify this process. Here, I first import the connector function from the data package. And then I use a connect with the parameter dbrp to create a connector to the dbrp website. Finally, I use the query function on this connector object with the parameter publication indicates I want to query the publication endpoint. And also, I pass in the search term CVPR 2020. If I run this query, it will finish in 1 second. Let's also take a peek at the result we get. It's a pandas data frame, and you can see all these results inside the data frame. Since the query function gives you a pandas data frame, you can directly apply analysis workflow you are familiar with on it using pandas, or just persist the data to disk. Also notice the highlighted await at the beginning. This is because the query function returns something lazily evaluated. Applying a await on that result will execute the lazy value and returns you the result. Connector uses this feature to achieve parallelism, which I will show you later. Now, let's check out how many records we gathered. It's 30 instead of 1996, as we saw on the website. Remember that by default, dbrp only returns 30 records per request. But with connector, you can also specify the desired record number you want to get by specifying the count argument. Now I'm going to add a count here and give it 2000 as the value. I run it again. You see, I get exactly 1996 records. This is one of the coolest features of the connector, because this enables us to get any amount of data without bothering to understand the API detail. This is because actually dbrp limits the records to return for each query as 1000. But since we specify 2000 here, connector knows that it should break it down to 2 queries instead of 1 and send them out simultaneously. After receiving all the responses, it will concatenate the tables into a single data frame. Next, I'm going to show you how to enable the connector to issue requests in parallel. This time, I want to see more papers related to CVPR. What I'm going to do is first copy the code to here, and then I remove the 2020 from the query term. And then I increase count to 10,000. I run the query. You can notice that this query executes a little bit slower. This is because we increase the count we want to get from the query. And this means we need to issue more requests to the underlying API. To alleviate this problem, we also have the concurrency parameter here to accelerate the query if you have lots of requests to send out. By default, the setting is 1, which means connector will send out the requests 1 per second. But if I increase it to 10, it will send out 10 requests in 1 second. You see, now it takes less than 4 seconds to get the data. At this point, you might wonder, what if you have a new website? How do you add it to our connector? It's actually fairly easy. You only need to create a config file for that, and then add it to our repo. You can see this is our repo. We currently have ThinkHub, we have Spotify, we have Twitter, and other websites besides dbrp and Yelp. You can also take a look at the content of the configuration file. Inside the configuration file, you mainly have 2 sections. One is request, another is response. The request section describes the information that connector requires to send the request to the underlying API. For example, it contains the URL, the method of the HTTP request, and authorization scheme and other stuffs. Inside the response section, it describes the schema information, which connector will use it to convert the response into a pandas data frame. To further simplify the config creation, we also provide a UI to generate the configuration file semi-automatically. Using these 2 lines of code, it will display a generator UI inside the Jupyter Notebook. This generator takes a request example, and it will return you a configuration file. For example, you can type in the URL of the request, and also the request parameters and other information is required to send out a request, and then click this button. The generator will send out the request and get the response, and then it will parse the response to get the schema of the underlying table, and then generate the configuration file for you. After that, you can just use this generated configuration file to send out the request using the connector, or even better, submit to our repo so that the community can benefit from it. That's it. I will give the screen back to Pei.
Okay, thanks for watching. Connector is a part of the data prep library. Currently, we're also developing a few other cool components such as EDA and cleaning. Feel free to check out. And finally, to summarize, dataprep.connector is an open source API wrapper that makes web API access easy. It speeds up wrapper development process for developers. It also standardizes calls to multiple APIs as a simple workflow for the users. The project won't be possible with our fantastic contributors. Don't forget to start us on GitHub and give it a try. Thank you.